Good afternoon, everyone. Good afternoon, class. Trước lớp mình học tới cái phần nào rồi các bạn? Bạn cho cô biết. Hôm trước mình học tới phần Global Criterion. Mình giải cái bài đó chưa các bạn? Mình giải cái example chưa? Tại vì cô dạy 3 lớp nên cô không biết là có lớp nhanh hơn, lớp chậm hơn. Bữa mình giải cái bài này chưa mấy bạn? Giải cái example này chưa? Bạn nào cho cô biết với? Châu. Bữa mình giải bài tập này chưa Châu ơi? Hoàng Châu.
Cô ơi, cô hình như chưa share screen hay sao á? Tại em...
Cô đang share screen.
Cô đợi em xíu, không thấy cái màn hình share của cô.
Các bạn thấy chưa ta? Các bạn khác có thấy không? Các bạn cho cô biết với.
Dạ thấy cô.
Hôm trước mình học tới rồi em. Bữa lớp mình đó là giải cái bài này chưa? Bữa các bạn không học ha. Tại sao mà cô hỏi không thấy biết trả lời gì hết. Ok. Ngọc Anh.
Dạ em học bấm lộn cô, em không có tìm thấy cái screen của cô.
Em không thấy hả?
Dạ em không thấy cái screen cô share, em chỉ thấy cái webcam của cô thôi.
Ủa các bạn. Còn các bạn khác thì sao? Các bạn nào nãy mới nói thấy cái slide của cô.
Dạ là khi em mở vô đầu tiên thì giờ nó không thấy screen của cô nữa cô.
Giờ để cô mở lại coi thử thấy không nha. Các bạn mở mic lên nói cho cô biết cái. Các bạn thấy không?
Dạ thấy rồi cô.
Giờ thấy rồi cô.
Rồi các bạn cho cô biết là trước học tới đâu rồi các bạn? Cái lớp mình đó. Bữa mình học tới này chưa? Cái example này chưa?
Dạ học tới đó rồi á cô.
Học tới đây nhưng mà mình đã giải cái bài này chưa?
Dạ rồi.
Giải tới đâu? Mình giải hết cái bài này chưa các bạn?
Hình như chưa cô, mình mới làm mấy cái constraint thôi à. Chứ mình chưa có giải cái phần.
Mình mới ghi ra cái này thôi đúng không?
Dạ.
Alright. Vậy thì hôm nay mình sẽ giải ha. Okay, so let me quickly review the methods before we're gonna show the example. So for global methods, for global criterion methods, so we try to minimize. Here we define Z star, right? Ideal solution. The first we should define ideal solution. Here that is 0, and that is GI. So the ideal solution, that is the optimal solution. Optimal solution. So right now we try to minimize distance here. Try to minimize distance because we try to find the objective is close with the ideal. Okay. So the formula length always is minimized. So I from 1 to k. K, that is the number of objectives you have. So here, the ideal solution minus with z, zi divide for here, I. So we have power p here, okay? So right now we try to minimize them. In here, how many objectives you have? 2, right? 2, so I equal 1 is equal to k. K equal 2. So in here, what we have? So the first of all, we try to find Z1 star, right? And Z2 star. So how can we find the Z1 star and Z2 star? I mean that the optimal value. How can we find the optimal value, everyone, of Z1? Who can remind me? So let me ask. They didn't come. Hello, come. So how can we find Z1? Z1 star. Here, the Z will be equal with F1. How can we find? Hello, Khánh. Yes, please, Jane.
We solve it subject to the constraint we have.
So it means we take like maximize F1 here, right?
Yes.
And with the subjective, we solve that. So we have solution here. Thank you, Jane. So we have the solution. So solution here will be equal with 130, corresponding with x1 equal to 100 and x2 equal to 200, right? So the same for Z2, we take the objective 2 with subject 2, we can have solution will be equal 150 and x1 will be equal with 250 and 0. So after we have this one, so we substitute in here, right? Z1 is 130 minus Z1. Z1 is minus 0.4 x1 minus 0.3 x2 divided for 0, right? P equal to 120 minus x1 divided to is P. Okay, everyone? Can you see it? So right now, the next step we will show what P equal 1. So if P equal 1, so what we have? Min will be equal to, so here equal 1, right? So we can get equal to 2 minus 0.00 x1 minus 0.0023 x2. That is minimi. And you have subject 2 here. Subject 2. So we have subject 2 that is x1 plus with 2x2 greater than 400 and 2x plus x2 greater than 500. x1, x2 greater than equal 0. Okay, everyone? So it means our problem original here. Original, we have multi-objective, right? We have 2 objectives. Maximize F1, maximize F2. F is similar with Z, right? So because I'm writing Z. So we will have 2 objectives. Right now we transfer become single objective. It means from multiple we transform to the single objective. So with single objective here, you see that is linear, right? Linear. Single becomes single objective. Linear programming problem. Linear programming problem. So we can solve that by simplex methods. So if you can see that global So global criterion methods that just only have transform from multi-objective become single objective. Is this? Why the solution we also use the simplex method? Okay. So any question for me? Everyone, okay? So that is P equal 1. From here, you can solve. That is two variable. We can use simplex or we can use the graphical methods, right? Graphical methods to solve. So if you look at this, look at the slide, so you can see here. That is the feasible region. Let me draw the feasible region. That is the feasible region. Okay, so what the feasible region? That is the objective function. This one objective function. So we can move parallels. So we can find the optimal solution. So maybe this point or this point. Right. So everyone, so B or maybe C here. We don't know. Just we can solve that and find a solution. Okay. So next, yeah, P equal 1. When we solve that, so we can see x1 equal to 200. Solve that problem. Here, x1 be equal with 250, and x2 equal 0. So with the solution like this, so we can substitute. So you can find z1, right? You can find z2. So z1, you substitute in here, right? No, just only the function. 500, you substitute in this one, that is 0, so 500 times with 0.4 equals 100. And x1 equal to 0, so f2 equal how many, everyone? So something is wrong here. Point C is x2, f2 is 100. F2 equal to 0. Everyone, so can you help me to substitute in here how many F1 and F2 we have? So if x1 equal to 250 is 0, so that will be 100, right? And F2 here it should be equal to 0 or 200 every. So, but never mind. Maybe my solution is not correct about the number. But everyone, the way you do that is you show that by graphical methods, and you can find x1 and x2. So you substitute x1 in here and x1 in x1 in here. You can substitute. So x1 is 250. So example like that. So you can find f1. And if you submit is x1 here, here is 200. Is 250. Yeah, it's correct. It's correct. It's 250. Okay. That is the point. That is the point. Next like this. Here we have like ideal, right? Ideal. So Z here. This point. And the point is 200. 0 here. Make it is minimum. Closest with ideal solution. Okay. Any question for me? No, right? So the next step would P equal to. So P equal to, you can see in the slide. So here is power 2, and we can solve the problem. But everyone remember here that is the non-linear. If P equal to, the mean here is different. The mean here, after you calculate, so you will have the function like this, right? Calculate the function is look like this. So for non-linear, that is a non-linear problem. Non-linear program. So how you can solve that? You can solve that by, you can use like Kentucky. You can use so some heuristic we also teach you on in the operation research 1 for non-linear. Okay, so we can find solution here. In here we don't use sim like now. Here that is a non-linear. One objective. nonlinear. Okay, so we can find the solution is here. Okay, so but with p equal infinities, so what about p equal infinities? Everyone, p equal to infinity, so how we can find that? Remember in the toxic methods, so min max, right? D infinities. So I call that a D. We will select which one will be maximized. So for example, here we compare which one is the maximum one. So we can put that in here and put an infinity. We select the maximize mean we select this one or this one, put in here. So that is maximize of this. And we show the problem by this. So because you remember here, if it are the infinities, so the infinities, we will select max, right? I already explained in top 6. We can choose max min to solve the problem. So that is the whole the whole method for solving multi-objective. So everyone in here, what you should remember for multi or objective, we should transfer to the single objective to solve. So, and what we get here is the optimal solution. In here, right, transform by global criteria. Okay, that is for the global criterion methods. Any question for me? Everyone, for multi-criteria decision making here, we need many knowledge from operation research 1, right? But in here, I don't go to detail solving problem. I want to mention about the methods support for multi-objective here. So when go with a single objective, I don't show that because we already study in operation research 1. So I have the slide like this, everyone. I have the slide here. So I transform F1, F2. But if you look at this, when we draw the what here, we draw about the the graph. So we use x1 and x2, x1 and x2, right? But in here, we can see that I use f1 and f2. So why I need to use f1 and f2 in this figure, everyone? So actually for two variable, right? Two variable, we just draw that in here and to solve that. But why we need to this figure? F1 and F2. Everyone, why? Why, everyone? So you can see that the optimal, no, the ideal solution that is 150 and 250 and 130, right? So the ideal solution, that is ideal solution, right? That is ideal solution. So when we draw that one, so C, D here, so you can see C, that is C, D, B here, that is the non-dominant solution. Is this, everyone? C, D, B, C, D, B point here. That is efficient solution is correct enough. So that is the feasible region, right? That is the feasible region. Feasible region. So what is the efficient solution? That is maxima. That is maxima. So here we have what? Maximize profits. Here, maximize profits. F1, that is the profits. Maximize profits. Here is maximize the production. Everyone, please. So CB judgment here that is the efficient solution is correct or not? So why that is efficient solution? So how can we know that is the efficient solution? Hello, everyone. You remember previous lesson? So let me call someone. Bùi Nguyễn Thiên Thu. Thiên Thu, Thiên Thư. Hello. Hello, Thiên Thu. Everyone just say something. If you don't know, just say don't know. Who can tell me, please? Khánh Linh. Nguyễn Khánh Linh. Hello, Linh. Can you hear me?
Yes.
Let's just say something. Say something. So, answer my question. So my question is, the judgment from C to B here, that is the efficient solution, is yes or no?
I think it's yes.
Yes.
Yeah,
Why do you say that is yes?
because I see that according to the definition, this is the best solution we can achieve without having to change at least one of the objectives, because we have two objectives here. So this is the best solution that can satisfy both objectives.
So you forgot efficient solution. Efficient, so yes, please. Okay, is all right. I will. So please, who just raise the hand? Who? So please.
I think that is it because each point in the line has the maximum value. For example, for the same x value, you will have the point in that line has the maximum value of y.
Everyone have any idea? Efficient solution, please. Yeah, Thảo. Thảo,
So
please.
I think C and B is non-dominant by each other.
Yeah, thank you. So that is the correct answer. Yes. C from C to B here. That is the non-dominant solution, right? So if you compare C with D here, if you get the maximized production, so you get the profits. So you compare C and D, right? C and D, that is the production, that is the profits. So C is greater than D about the production, but the profits is lesser than. So C and D here is non-dominant. So from C to B here, that is the collects all the non-dominant solution is efficient solution, or we can call that is the Pareto front. So if you look at in the slide, okay, look at the slide here, you can see if we show the figure by x1 and x2, so we cannot see efficient solution. All right, but if you can use like the figure, we transform f1 and f2 here. F1 and f2 can show you the efficient solution. Okay. Everyone, got I mean? Got I mean, everyone? F1 and F2 can show you here. So also can show you the ideal solution. So right now we try to find what? Try to find the efficient solution here, close with the ideal solution. Right? C and D in this is 2 points. If B equal 1, that is C. If B equal 2, that is D. C, so the point that is C. If E equal 2, the point is D. So everyone, have any question for me? Okay, I have no question. So what I'm trying to say that with you that I want to show you here and remind you ideal solution and efficient solution. Các bạn ơi, hôm nay mình sẽ học tới tầm khoảng 3 giờ kém nha các bạn, 3 giờ kém thì lớp mình sẽ nghỉ sớm. Đáng lẽ là Sơn sẽ take care cái phần sau, nhưng mà tại vì hôm nay là cô phải tham dự cái tuyển sinh sau đại học của các bạn, thì cô phải tập huấn cái lớp đó, nên là lớp mình sẽ sớm, khoảng tầm 3 giờ kém 10 hoặc 3 giờ kém 15 thì cô sẽ cho lớp mình nghỉ. Nên là các bạn có thể không giải lao được không các bạn? Không giải lao được không các bạn? Mình sẽ được nghỉ sớm. How do we have?
Cô ơi, cho em hỏi là point B mình ở đâu có vậy cô?
Cái point P đó hả? Là từ bên này nè. Em muốn vẽ được cái này đúng không? Em phải dựa vào cái này. Đây. Vậy thì làm sao mà mình ra được cái này? Thì mình có f2 bằng x1 đúng không? Mình có f1 bằng 0.4 x1 plus 0.3x. Thì bây giờ em phải rút cái này là em đang viết x theo f đúng không? F cái này là em đang viết theo dáng dạng này. Em đang vẽ sơ đồ theo dạng này. Thì bây giờ em sẽ vẽ sơ đồ theo x1 bằng x2 x2 be equal something related with f1 and f2, right? Có thể transform nó bằng có thể là a f1 plus with b f2. Giờ cái f1 and f2 này nó trở thành biến, x nó sẽ trở thành hàm, được không? Thì ở đây nó cũng sẽ trở thành ở trên này. Cái này đây nè. Thì em phải vẽ cái này theo fx đúng không? X này nó sẽ bằng cái gì đó với f2, cái gì đó với f1. Giờ mình chuyển lại thành f1 and f2 thì mình sẽ vẽ ra được cái này. Vẽ ra được cái miền này. Em hiểu ý không Phương? Em hiểu cái đoạn này chưa? Ok không? Hello Phương. Bạn rồi, ok. Vậy là hiểu rồi, hiểu cách làm rồi đúng không? Mình chỉ đổi thôi, mình chỉ viết hàm theo biến, giờ mình viết biến theo hàm thì mình sẽ vẽ ra được cái này. Ok. Rồi hôm nay cô sẽ có dạy lý thuyết rồi hôm sau mình sẽ lên bài tập nha. Okay, so that is all for global criterion. So let me move on to the compromise programming. So global criterion, that's the one method. We use that for transform multi-objective to single objective. Okay. So right now, today's lesson, I'm gonna share with you another method, that is the compromise method. But they have something similar. So let's see how similar. So compromise programming, why they have the name compromise? Compromise means they try to get enough satisfied, enough sacrifice, and they select that one. Compromise có nghĩa là thỏa hiệp. Compromise. Okay. So here they have, like I give you the cost. Investor, of course, we are looking for a business in which management can buy low, sell high, collect early, and pay late. Business plan need to spell out how close that the new venture expect to come. So the idea is the same. So we have the ideal solution here, right? Because we want to buy low, sell high, collect early, pay late. But we never reach that point, right? And we never reach that point. So we try to close with this one. But see how they can do. Okay. The compromise programming, actually they also pay on the distance. That the idea is similar with the global criterion. Okay, let's see. So let me talk about the idea of this one. So the idea behind the compromise that either find out the set of the solution closest with the ideal point. We need to introduce the concept of distance. So here the same. Also try to find the closest with the ideal. They also have the same Euclidean distance. They also have the Manhattan distance, right? And also have the trebuchet. So let's go one by one. So the concept of distance measure. So as I tell you and mentioned many times, so for the Euclidean distance is mean, so we have one point here, right? So we take this one, u plus with this one, and we take 1/2. We get that distance. So distance from here to here. That is Euclidean distance. So, but we extend the n-dimension space. N-dimension space. So here is not one, not one. This point to this point, right? But we have many. So we can see that from J here to N, J to N. So here J is from 1 to 2, right? Here from J is from to N. We extend that is N dimension. So here is also 1/2. Everyone, you get this, the idea of the n-dimension space. So here that is the 1, here's 2. So if you have n, so you have, that is just 2 dimension. You have more than 2, 3, 4, 5 is n dimension. So n dimension is hard. We can display that in the 2 dimension. So they can write like this. J from 1 to n. Okay, so in the compromise, they have like the definition, the family of LP matrix. So here, that is the families LP. P, that is the so here they have the family P. 1 P can be equal 1 to T to infinities. So here we have P. We also have 1 over P. It's like what we study in like top 6 in global. It's in global we don't mention about 1 over P, right? But here we have 1 over P power here. So actually, in the global, everyone. So they have the point here. We compare with the Z star, right? Here we have that point ZI. But you can see they didn't divide for in this one. They divide for this, right? Divide for that. But in here we also can see in this is they also divide. Let me tell you later about. But let's talk about the family of the matrix first. Okay, that is the distance from this point to this point, to point 1 to point 2, so they can calculate the distance. We talk about here. We just talk about the distance. So, for example, and I take example for L1. L1 is mean P equal 1. P equal 1, so we'll look at this. So we have the point here that is 2 and 3. We have a point here that is 10, 8. Right. So we could calculate for L1. L1 is mean 2 minus 10. 2 minus 10. So here is power 1, right? Plus with 3 minus 8, that is 1, equal to 30. So if that is 2, so equal 2, so here that is equal to, and this one will be 1 over 2, right? So we get that is 9.43. So you can see if P equal 3, P equal 3, so we get that point. So P equal 8, so you get that. If you look at this one, so when P increase, so the value of L here will be decrease, right? And so when we get the infinities, so L is infinity here is 8, right? A infinities, so if it's infinities. Infinity. 1 over infinity. So because here that is phi infinity, that is a infinity, right? 1 over infinity. So we compare a is larger than phi, so we just take a infinity. So here a infinity is 1 over infinity, so will be equal a. Is this? That is a. So if you look at this here, if b equal 1, so L will be equal 13. P equal infinity, so L will be equal 8. So it means L will be from here I is P. A greater than 8, lesser than 13. So if we have 2 points here, so it means the distance, the point from here to here will be equal 8 to 13. And minimum that is the 8, and maximum is 13. Okay, that is about the concept of distance. Is this everyone? P from 1 to infinity. Okay, so remember everyone, we studied the distance from here to here is just only, usually we think about 2 dimension, right? Euclidean, but actually it's not. If we consider different p, we have different value, and we can know that the distance here can be run from 8 to 13, belong to p. So, but everyone, in a strict 2-dimension geometric sense, the use of LP metric for value of the parameter p greater than 2 is meaningless. So it would mean the existence of a distance shorter than the straight line. Okay, and the use of LP metric is very useful, if not used in the geometric sense as a measure for human reference. So what does it mean? So they said that p should be equal 1 and 2. Is if greater than 2, so it's meaningless. Meaningless in the meaning here we consider about the geometric sense. Geometric sense. So if you can see here, they said that we already know that is the distance between 2 points. The minimi, that is the straight line, right? That is the straight line. So straight line, that is the minimi distance. That is the distance from 2 points. Straight line, that is the minimum. But in here we have lesser than that. So the distance between 2 points here, that is 9.43. 9.43. if you use the Euclidean, so we can calculate the distance from here to here, that is this. But we can find that when p equal infinity, so the distance between 2 points here equal 8. So they said that a lesser than here. So we cannot say have something smaller than straight line. So that is not meaning. That is the meaningless. You know what I mean, everyone? But why we need to consider different? Why we need to consider different p? Any p. P1, P2. That is enough. Why we need to consider P3, P4, P5, P6, and P infinities? Because when we make the decision, everyone, so the human, we can use that for measure for human preference. So if for engineering, P equal 1 and 2, we just working on P1 and P2. But for business, in the business area, we have different. They don't consider just 2 dimensions. They have like 3, 4 dimensions. But for in engineering, we just use 2. 2 have the meaning for geometric set. Okay, so that's why we have know about the L infinity. So for example, I just think about example. We have like 1 plus 1 will be equal to. It's definitely equal to. But for human preference, so let me take an example. So for example here, okay, that is the first alternative. That is second alternative. Okay, so if you look at this 1 and this 2 here, no. So example. So you can see that this area larger than the left side. But for human, if they are positive, like the optimists, they can choose the right side, but they are pessimists, so they will choose the left side. So it's not about the larger is the better. No. Right? So here that the area is larger, we should select this one. But for the optimistic person, so they will choose this one, but the pessimistic. So I'm taking example for you is mean I'm trying to say that is when we consider the distance here, consider distance. All right, the minimum distance, this point to this point, that is the straight line. But we still have another distance shorter than the straight line here, right? So when we say that is the correct is larger, we should correct larger, so choose this one. But no, the human, they pay on the human preference or the human opinions, and they will select. Okay. So right now, for the compromise, so we should know about the best compromise solution. The best compromise solution. So what is the best compromise solution? The best compromise solution is the nearest solution to the ideal. So actually, they also define the ideal here. They try to closest with the ideal. Minimize distance here. Okay. So the degree of the closeness between the objective and this ideal. So you see that, take the difference. That is for maximize. So if z is, if here that is the minimize, so we take zj minus g star. Okay. Should be normalized. Deviation should be normalized. So how can they normalize? Here they normalize. They divide for NTs. Check this. Divide with NT ideal. You already know how we identify the NT ideal, right? It means negative ideal. So this is will be D here. Will be greater than equal 0, greater than equal 0, and lesser than equal 1, right? But here 0, 0 also should be this one, the ideal. But actually D here, D here, B equal to Z star minus Z, minus Z star into to be greater than 0, greater than 1. If that is equal to 0, if equal to 0 here, equal to 0, so Z will be equal with the ideal. So that it cannot happen, everyone. So ideal is something we cannot reach, right? Just close, so cannot equal. So that's why here we don't have equal to 0. And this one, if equal 1, so equal 1 is mean this one will reach the negative. Also, we don't have any point to reach negative ideal. So should be better than 1. Not equal. Okay. Any question for me? So that is D, that is L. L is mean we study about the general knowledge, the distance, right? D here show what? D here show how close, the degree of the closeness, right? Degree of closeness Z, right? Because right now we take the different Z and Z ideal. That is show the degree of the closeness with the ideal solution. Okay. So right now we apply this one. Sorry everyone. Okay. Okay, everyone. So right now we apply this one, the distance here. Apply this. Calculate. Actually, here we show the distance, right? The closest. Okay. So right now we can play LP. LP B equal what? G equal 1 and WJ DJ P. So W here show what? That is the weight of each objective. So for example, in the previous example, we have objective 1 and objective 2. It means you maximize profits, right? You maximize profits and you maximize the production. So which one you give the high weight? So if production you give 0.6, here you give 0.4. So that is the weight here. Okay. Which one you think that is the important? So D, that is DJ. So here, if you have J, that is J. So it looks like this. The different one with the Z1, different Z2, start with Z2. But in here, they just divide for Z star, right? But here you see that the different Z negative. So in this case, we must to define positive and negative. Is this? Okay, so let's go with this example. So look at the example, everyone. So we have A dash B dash C dash this, that is the ideal, and this is the anti-ideal solution. So we have Z1 and Z2. Z1 and Z2. So if you have, that is the solution, A dash is one solution, two solution, three solution, right? Right now we have like this. But how we can get the solution here, everyone? We get the solution is mean we take single objective, we solve with the subjective, right? We get the optimal solution. We get the optimal solution. So if you look at this 1, 2, 3 here, how can we define the ideal? So we define the ideal, we select this one, the maximum of this one. And the negative we can find here, negative, that is negative, right? The biggest one, that is become positive, that is ideal solution. Less here, that is a negative. That is corresponding with Z1, right? For Z2, so here, that is the maximize, the casual label. Casual label is less is the good, less is the better. So that is the ideal. Here, that is the negative ideals. So what is the difference between this payoff matrix with the global criterion, everyone? So for compromise, the compromise, for example, here you have Z1, you have Z2, right? You have solution A, B, C. And after that here, that is the max is better, that is mini the better, okay? So we select here Z star, and here we get that is Z negative ideal. So we select here, select that from here. That is the compromise. But about the global criterion, global is mean what? We also have like Z1, right? We have Z2. So the point max Z1, so you have here we have X1, X2 star. That is max Z1 optimal, right? We have here and here. So that is the ideal solution. If here ideal solution, that is right. That is the negative ideals. We also have this point, right? This point is that is 1, 1 is 1, 2 star X 2, 2 star. So we get this. Global criterion, that is the compromise. You see the way they define. So next, right now we calculate D. So I'm eliminating this. D1 will be equal to Z1 star minus with Z. What divide from Z1 star 1. Right. That is D1. So D1 we have what? Z here, right? Z star minus what? Minus this point. So divide for this. This one will be have 166,775 minus, right? And in here we have minus what, everyone? So D here, we have D, this one, the same. So that will be equal 1, right? So is equal 1. Here you do the same. You take this one minus this one, you divide for this one. So you get this. Same, we calculate for D1 and D2. So for here we get L. Right now we calculate L. L is W, but we trick two objective here to the same weight. So we can get this one. So compare with here that equal 1, 1, here that equal 0.85. 0.82. 0.82. So it means what, everyone? If we look at this with the same weight, be close with the solution, ideal solution, right? Because the distance from here to here smaller than 1. Here you see that 1, 1, but this is smaller than 1. Here is smaller than 1. Even the weight in, we change the weight, but we can still see that is the distance is smaller than 1 here, smaller than 3. So B closest, right? Okay, so you have any question related with this table? Everyone, this table first. Let me see. Any question? Because it's
Can I ask something, teacher?
yeah, sure.
What is the difference between y1 equals 1 and y2 equals 1 and y1 equals 2 and y2 equals 2?
Yeah, it's different because you trace that. Here we trace that is equal 1. So if you give weight equal 2 or equal 3. So when I give you that is 0.6 or 0.4, that is already normalized. So I think, for example, here the brackets, I trace the brackets here is 3 times. Here that is 2. Here that is 2 times. So you can see in here, you see, I give weight for the The objective 1 is 3 times. So weight for objective 2 is 1 times. So it means here we don't mention about the ratio. We don't mention about the ratio here. For example, if you see that is 1 1, same with 2 2, right? You want to ask me the question like this, right? 1 1, 2 2.
Yes, I think they are
here,
the same.
Yeah, but here we just check the trial. We check in here what we want to do. If we show that, we try to demonstrate that B closest solution. So it means even we try to change value here. We try to change the value here. So you can see I'm trying 1, 2, 3, but I keep weight 2 equal 1. You keep 1, keep it 2. So I try to like give a different weight. But with different weight, B still that is closest. So that meaning. If you give 2 here, it means you see that the objective 2 that is the 2 times important. Here that is the 2 times important. Or like this. Okay. Could you please upload the new slide for us? Ủa các bạn, cái slide này không giống slide kia sao? Giống chứ. Giống mà các bạn. Đâu có gì khác đâu. Chỉ có cái bìa khác thôi chứ nội dung là giống nhau. Chỉ có cái trang đầu tiên khác thôi chứ đâu có gì khác đâu. Nó giống nhau mà Uyên. Ồ, cái slide này khác slide kia sao? Tôi chỉ có thay đổi cái.
Cô ơi,
Sao em?
cô cho em hỏi vậy là cái D1 của cô trên bảng á, cái mẫu số là ideal trừ cho non ideal không cô?
Cái mẫu là trừ cho cái negative đó.
À dạ dạ.
Các bạn ơi, còn câu hỏi gì nữa không các bạn? Các bạn có thể hỏi nhanh giùm cô để cô có thể vào học cho kịp không? Cô chỉ còn mấy phút nữa thôi. Ok, thôi các bạn còn câu hỏi gì nữa thì hôm sau trong cái lúc mà các bạn ấy thì các bạn có thể hỏi cô ha. Các bạn có thể về ôn tập và các bạn có thể hỏi. Tại vì bây giờ là hết, cô phải vào học. Sơn em có cái link đã học không? Sơn gửi cho cô cái link dưới Sơn. Okay, all right, everyone. So, have no questions. So, see you next week. Bye bye. Hôm nay mình nghỉ sớm tí nha các bạn. Tại vì tuần này trường mình thi. Đi cao học. Ok, bye bye nha. Giờ hoài không thấy bạn nào bye bye cô hết. Cô phải bye bye lần nữa.